Hi, I'm Karimi, a graduate student in the group of Dr. Babicheva at the EC Department of the University of New Mexico. I'm going to talk about the tool developed by the group members and allowing users to run calculations for a single nanosphere. The tool is freely available through the resource nanoHUB.org. It is an NSF-funded portal based on community contribution and geared toward education, professional networking, and interactive simulation tools for nanotechnology. Let me first comment about the general motivation of the work. The localized surface plasma resonance property of metallic nanoparticle has been widely exploited for chemical and biological sensing, and recently COVID-19 has been successfully detected by plasmonic-based biosensors. Calculations performed with our tool gain insight into the enhancement of light at the nanoparticle and its applicability in nucleic acid tests and viral disease diagnosis. This is a very simple yet quite useful tool. With this tool, one can calculate a wide variety of nanoparticle scattering properties and cross-sections. This video will cover the tutorial for the tool that uses mean theory to calculate absorption, scattering, and extinction efficiency for an isolated spherical nanoparticle. The user can define the materials of the nanosphere and the surrounding environment. One can also define the nanosphere radius as well as the number of desired modes. It means the calculations are performed for dipoles, quadrupoles, octupoles, and high-order modes. Here we see the user interface. I've already logged in. I'm on my nanoHUB homepage, already navigated to tools launching page. We can find the tool by searching its title as "Me Calculation of Single Nanosphere Cross Sections." Let's type it here. There you go. If you have already added the tool to your favorites, it can be also accessed from there too. As an alternative for quick navigation, the URL address will take you to the tool homepage. It's alias EXTCS, abbreviated from extinction cross section. Right? Let's jump right in. Now I'm going to demonstrate all the tools functionalities. I'm going to click the tool button and start a simulation tool right here. We launch the tool and the session starts. We are going to click each option one by one and learn what they do to get an idea of how the tool works. Let's dive right in. The first thing is we need to choose the radius of the nanoparticle here, which is it is in micron. If you hold the cursor for a couple of seconds next to each option here, a short note appears next to it, and then it is guide on parameters and options for the user. Now I'm clicking next to the nanoparticle material and selecting refractive index from the category here. Alternatively, one can pick a constant refractive index which is hidden from the initial selection. Let's click and the window pops out. It shows an interactive option in which user can insert either their desired constant refractive index or permittivity. Next, we plug in the refractive index of the surrounding environment here. Then next, we define the wavelength range. Here, there are a few options. In this case, I'm setting up initial point is spectrum, endpoint here, and spectral resolution here. That is by what step it is incrementing. Last here, there is a choice for the number of modes. One can use the Wiscombe criterion, which provides a good empirical estimate for dielectrics. The criterion depends on the refractive index on the surrounding medium, nanoparticle radius, wavelength of the incident light. The second option is when the user chooses to work with desired number of modes. The user can manually insert the number of modes, including the calculations. We use the switch button here and type, for example, 17. That's it. And then finally, one needs to hit the simulate button to run the calculations. It takes a few seconds or more, depending on the number of modes or spectrum range and resolution, availability of nanoHUB resource at that moment. Okay, when the calculations are done, the tool plots that as you see here. One can click and drag on the lower right corner here to enlarge the image. First, again, um, by holding the cursor on each curve, there is a description about them. One can also find the curve relations by hitting the right arrow here. And then, moreover, the abscissa and ordinate axes are adjustable. You see they give different options. For example, one can select the logarithm scale here. In the results section, we see a line called total here, which is extinction, scattering, and absorption concentrations of all modes based on the criterion selected manually. Next, we see concentrations individually, break them down into modes of electric and magnetic types here. The plot shows up to 10 modes here. If the user has already selected more than 10 modes, they will be taken into account and included in the total, but only 10 modes are shown in this plot individually. Further, we have the data of the refractive index here, real and imaginary parts considering the calculations. Next one is the tool shows the number of modes that were into account, as you see 17 in our example. One can modify the structure setting and rerun the calculations. For example, this time I pick another radius of 0.1 micron and stick to the default number of modes defined by SCOM criterion. And the rest is the same. Let's hit the simulate button. Okay, all the calculation results in the session can be accessed in the bottom panel here. As you see, there is a brief summary of how those simulations differ from each other. Okay, you can download the data with the calculated results in the TXT format here. And then use your post-processing of this data in the software of your choice, for example, MATLAB. One can click keep for later and it will be saved on the user's dashboard here. It will appear in the user's list of sessions. nanoHUB allows users to keep up to 3 sessions at the same time for free. Also, on top of it, here we see question tab. You can view ask questions there, and also there is an option to save simulation again here and load it whenever you want it. Alternatively, one can share the tool with other users to have access and modify calculation parameters. If one user changes anything, those settings will be immediately synchronized with the other user. If you have already started a session, it's going to stay there open for a long time or until you manually close it by clicking the terminal button here. Have a look at these screenshots and abstract for more information. You can launch a session and play around. After watching this video and testing the tool, I hope that you add this tool to your favorites list so that you can get back to it quickly. Thanks for watching.